Welcome all. Thank you very much for tuning to my channel. This is section 4 of the ozone technology course. In this section, we will be dealing with ozone hole and the toxicity of ozone. We also will be dealing a little bit to show that ozone is a means to measure the pollution. You'll note that most people relate ozone to the ozone layer. There has been a continuous formation of ozone in the stratosphere, assisted by lightning during the thunderstorms for millions of years. This ozone layer is very important and it protects the Earth from receiving much of the harmful ultraviolet rays. This ozone layer absorbs the ozone and dissipates its energy, releasing only oxygen. Unfortunately, with the outcome of the industries, harmful chemicals and a lot of pollutants from industries and vehicle emissions have been responsible for destruction of much of the ozone, and in some areas have caused the ozone hole. There is a continuous array of UV from the sunlight that shines through to the earth. Further, lightnings from thunderstorms regularly occur in the lower part of the atmosphere, and during these times the oxygen in the atmosphere is dissociated and recombined to form ozone. This ozone envelops the earth and protects the earth from the harmful rays. UV reacts with ozone and it reverts to oxygen, and there is a reduction of the UV. The destruction of ozone generally by gases such as CFCs or the original refrigeration liquid and VOCs or volatile organic carbons generated by industries destroy the ozone and causes the ozone hole. Through this hole, the harmful UV rays pass in and come into the earth and exposes the human beings and eventually causing cancer. It is noted that ozone destructs CFCs and used up. The problem now is the industry, after banning the manufacture and use of CFCs, still allowed recycled use of CFCs and to allow to deplete slowly in the atmosphere rather than destruct it immediately, which is a safer method of destruction that can be done using the ozone manufactured in the ground. Unfortunately, because ozone was not accepted as a venue for applications or tool for applications, this was never considered. In this slide, I will explain to you how ozone is used to measure the pollution. As you will understand from the last slide, the harmful gases that are released from vehicles and industries such as nitrous oxide, nitrogen dioxide, etc., they can also float up onto the ozone layer, and in the presence of the UV rays is converted to nitrogen oxide or nitric oxide as you call it, and oxygen or atomic oxygen that will then react with oxygen, molecular oxygen, to form ozone. So you will understand that the pollutants produced by the industries are responsible for the formation of ozone. And what the government does now is they measure this ozone level or this ozone concentration produced by the toxic agents and related to the amount of pollution in the atmosphere. In other words, the higher the ozone level, the higher the pollution. Of course, this gives an impression that because we are measuring the amount of ozone in the atmosphere, and when you get a high ozone level, it means there's a high pollution. That is, we are unwittingly putting the blame on ozone as a pollutant rather than the toxic chemicals and gases that are released by the industry. The next question is, of course, what everybody is under the impression or want to know: how toxic is ozone to man? You will note that the Earth has its own ozone layer, and constantly ozone is being produced by lightnings and thunderstorms, and near the surface area you may have as much as 0.01 to 0.1 ppm of ozone after thunderstorms. Our nose can detect ozone at a concentration as low as 0.02 ppm, and I will give you a table later which gives more information on this. Ozone is a sweet-smelling gas at the low concentration, representing the freshness that you note in the seaside. Once the concentrations start going above 0.01, ozone will start irritating our nose, irritating our lungs, and as the concentration increases, the irritation increases tremendously. Because it's nauseating and irritating so much that it is almost impossible for us to remain in the environment that has that much of ozone. I refer this in the case of where we do applications of ozone, where you are in a room and you find there is an ozone leak, and then you find the smell, you get the smell, and you know there is an ozone leak. What you try to do, you try to shut it off before it goes off, or you walk away from the room to save yourself. This is the data table I have been referring to you in the earlier slide. In more detail, all these concentrations are in parts per million, volume air concentration. The lowest value detectable by hypersensitive humans is 0.001, and at 0.003 there is a perception odor in the lab people can detect. It can be detected by normal persons. At 0.02 there's a threshold of perception in the laboratory. At 0.001 to 0.125, there's typical ozone concentration found in the natural atmosphere. These levels of concentration vary with altitude, atmospheric conditions, and locale. 0.02 and 0.040 ppm, that's the total oxygen concentration in some major cities. In 1964 that was measured, and 95% approximately or greater of these are generally accepted to be ozone. The CSA limit for devices for household use has placed 0.04 ppm as sustained concentration in test room. The maximum allowable concentration recommended in air conditioning systems, ventilator space, etc. is 0.05 ppm. You note that a maximum allowable concentration in industrial working areas is about 0.10 ppm. Permissible human exposure 8 hours per day, 6 days a week. Continuous maximum ozone concentration allowable 0.1 ppm 8 hours a day. I mean, it's quite a long exposure time. And there are some concentrations of ozone 0.15 to 0.51 ppm in many American cities. Now, of course, we have to establish some sort of safety levels, and it has been found that at 0.2 ppm, prolonged exposure has got very little side effects or effects. The nostril irritation only starts at 0.3 ppm. The ozone level at which sensitive species of plant life begin to show signs of ozone effects is also 0.3 ppm. The ozone level in Los Angeles, California, during smog alert can be up to 0.5 ppm. In LA, smog alert number 2, up to 1 to 2 ppm, and it becomes extremely dangerous, and people are normally advised to stay at home when such a situation arises. Then you have the 3-hour exposure at 12 ppm was lethal for guinea pigs. That's what they found. And welders have been exposed up to 9 ppm, plus other pollutants, have developed pulmonary edema. Chest x-rays were normal in 2 weeks, but 9 months later they still complain of fatigue and exertional dyspnea. That is very difficult to breathe. And when it comes to 25 ppm and upwards, ozone is very dangerous and it can cause death. Please understand that in all our applications, it is we'll never use as up to 5 ppm, even a 5 ppm in an atmospheric ozone concentration. In application liquids, we may use that concentration. In generally, almost all our applications, we use between 0.1 and maybe 0.4, 0.5 ppm in water, and some chemical reactions, we use much higher. This is a toxicity chart of ozone. There's one thing I would like to inform you, that while we say ozone is toxic, yes, ozone has one part of our body, particularly the epithelial cells of our lungs, are very particularly and specifically sensitive to ozone, and that can be destroyed or damaged, causing lung problems, difficult to breathe, and you'll find that it's very high levels, you have got the permanent toxic region and the fatal region. And at much lower levels, you may have a toxic region, but it is reversible. And still lower regions where it's only symptomatic, that's when you get irritation, etc. It's non-toxic region and it does no damage to your body. Of course, much lower levels you may smell the ozone, but at that particular smell, you may not have any symptoms, so that will be the non-symptomatic region. So you will find that the allegation that ozone is toxic and should not be used by the chemical and drug industries in the applications we want to use is totally untrue. This chart just shows the relativity of people who might be affected to the number of people who could possibly die. This is only diagrammatic. First of all, as far as I remember, as far as I know, in the 40 years I've been in ozone, there has been no record of deaths. There is no record of emergency department visits or hospital admissions because of ozone toxicity. And schools, of course, unless children are exposed to ozone, I don't think anybody has been also absent from school because of that. Obviously, when there is a very high ozone levels in smog and etc., it is quite likely that along with all the other toxic gases, ozone can also be involved in causing respiratory symptoms that may lead to hospital or doctor visits. Generally, ozone is pretty safe to use. The table here indicates an index value the government is using to warn the public whether the environment is safe or unsafe, or whether or not they should be locked up themselves, they should stay indoors until the dangers go away. As you will notice that, as I explained to you, the pollution is determined by the amount of ozone liberated that is used to calculate the index values. So if you have 0 to 50 index value, it's good, no problems. 51 to 100 is some moderate pollution. 101 to 150 is not terribly healthy. With 151 and 200, it is very unhealthy. And 201 and 300, extremely unhealthy. And once it goes above 301 to 500, it is dangerous and hazardous. And in both cases, anything between 151 and to above 300, it is always advisable to, as much as possible, to remain indoors until the pollution is dissipated. This chart shows how the pollution takes place and ozone is released. The vehicles generate the nitrous oxides or nitrogen dioxides, which is converted by UV in the upper layer of the atmosphere and broken down to nitric oxides and oxygen atoms, which link to the oxygen molecule to form ozone. So the relationship between ozone levels and pollution has been established. And by measuring the extra ozone level that is above the base level, we would be able to say or estimate how much vehicles and industries have been polluting the atmosphere. Finally, we come to answer the question, is ozone a pollutant? And the answer is no, ozone is not a pollutant. Ozone is a means to measure the amount of VOCs and nitrogen oxides and nitrogen dioxides that have been generated by the industry and vehicles. And by measuring the amount of ozone that is released by these, we have been able to relate the pollution. Ozone is not a pollutant. Ozone, in fact, is used to destroy pollutants. Now we know that ozone has been very unfairly blamed as a pollutant. The acceptable standards have already been discussed, and we also know there is a basal level of ozone. We also know that at most of the concentrations we apply in the industry, in medicals, etc., water treatment, etc., the level of ozone we use, the concentration of ozone is far less than the actual ozone concentration that is harmful to us. I'm not disputing that also ozone is toxic to the lungs, but I say that ozone is not toxic to any other part of the body. I've been exposed to the reasonably high concentrations of ozone during my work experience, but cautious behavior will always ensure safety. I've installed ozonated pools using residual chlorine as injection, but never had to take away any ozone, residual ozone from the water that I pumped ozone in. That is what the government recommends, that we remove the residual ozone, because the small amount of ozone that is possibly breathing when we are swimming will cause damage to our lungs. And you will understand that because the treatment is, the ozone is so low, and often the basal ozone level is higher, this is an unfair allegation. There's another thing we have to understand, that ozone cannot be bottled. So you can't have big factories producing ozone and causing toxicity like they do for chlorine and chlorine dioxide. Ozone, when bottled, will convert to oxygen within the next few hours, and there's no purpose of bottling ozone. So what we have to do is we have to produce ozone on site and apply ozone as soon as it is produced, before it is destroyed or before it dissipates to oxygen. What we have to do is to make sure that during the area where ozone equipment is being used or application is being used, we prevent any excessive ozone buildup, because we can always immediately notice if there is any ozone leak, because our sensitive nose would advise us, and we will immediately tend to stop that leak so that we won't be exposed to that ozone much longer. I've given some references here on toxicity of ozone, and if you are inquisitive or you want to know more about it or concerned about ozone, I would advise you to look into some of the literature that is available and get yourself in the know of the actual state of ozone toxicity. This is the end of session 4. Thank you very much for having the patience to listen to me. Please proceed to session 5, which will deal more on safety risks on ozone and chemicals. If you are new to this channel, please refer to sessions 1 and 2 that will explain the course program or its details, and 3 and 4 as the initial part of the course. If you like the course, please tick the like icon, or even better, the subscribe icon, where you will be informed of future session releases. Thank you very much and have a good day.